Hello, everyone. My name is Marco. I'm the CEO of Memgraph, and welcome to another Memgraph community call. So today we've got Vishal, who is the CEO and founder of Quark Labs, is bringing the basically the context from the messy documents to the surface. Um, so Vishal has been building the platform, and we basically want to showcase that to everyone. So Vishal, over to you.
Awesome. Thank you so much, Marco, for having me here. First of all, I'm really excited to actually talking about how we actually take the information and the documents across different sources and actually create the universal context layer where you can actually easily ask questions or even use to even define and create workflows on those top of the documents. While building this, we built our platform using Memgraph. So I'm very, very delighted and to be on this platform to show how we have been using Memgraph and also how you can use Memgraph to even convert a different set of documents, whether it could be forms or it could be PDF or it could be even a most handwritten information, and how you can actually create those information as a part of the graph itself. At any time, if you have any questions, I will be monitoring the chat. Feel free to ask the questions. My intent is also to show what we have, but also to learn into what you're thinking about and what are the issues you face when it comes to the document itself. Awesome. And I'm going to share my screen. I'm going to move this thing. So what I've done, let me actually give you higher level value of what the Quark Labs looks like as a platform. And then I'm going to go into a demo. I have curated some of the most messiest information from the handwritten and IRS forms. So I'll actually start by looking into this and how we actually go and do the document intelligence on top of that. Sharing my screen. And let me know if you all can see my screen. Awesome. So here, what we are going to do, first I'm going to show you the Quark Labs. So what we do, we are the platform which can connect to the all set of documents sitting across the different corpus or different places. So what we do is like we connect to the Azure S3, blob storage, GitHub, Box, Hugging Face, even local file storage. And then one of the key piece when it comes to even document intelligence on the one or two file, that you have to connect a file itself, and then you have to build a full workflow around that. And I faced that into my own job at the time, that you connect the file, you extract the information, then you figure out how to take the information and create the context on the top of that and build more on that. But let's say if you have documents, you have millions of documents, or if you have hundreds of documents, or if you have documents which you on the S3 where the new documents keeps coming in, and then you have to continuously build that pipeline. So in order to do that, what I've done, I've actually created all these documents part of S3. And you can see that there are a couple of information and PDF documents I already have on S3 itself. You can run our flow from here, which is generate markdown, or if any actually extract the information, and it will automatically extract the information. Doesn't really matter how many files you have or how many pages of files you have in the object storage or even on your local file storage. I want to go with the couple of documents one by one. So here, you can see one of the documents which I got. It contains the information, and this is a markdown. This is rendered markdown. I also have a raw markdown, so you can actually take a look into it. But here you can actually see the information which we actually found, where you can see the file itself does not have has already had like information to test, basically touching each other. Also at the bottom, this is where most document intelligence platform end up failing, because you can see there are multiple grids. This is actually a form. This is not even a table. So what we do, we actually look at the information and preserve one-to-one mapping of the information as we are creating and extracting the information out of the PDF. That information could be handwritten files or it could be scanned files. It does not really matter. Once we have extracted all this information, as you can see here, we in the raw markdown, it looks like this. But once we have extracted the information, we also create the JSON view of that file too. The JSON view is actually needed when you are actually not using AI to read the markdown. This JSON view also helps me to create the entities into Memgraph. And as we're creating JSON views, we also create all the identifiers, which is all the PII information in it. So we are not only reading the file, but we're also creating the schema of the file itself that can be used either for the AI use case or non-AI use case as you're looking to parse the information from the document. Let me show one of the most the amazing documents which we have, which is a handwritten file. You can see that in this file, there is a lot of handwritten information, Whitfield, James, and the taxpayer identification number. And sometimes it gets hard to even actually figure out like how the handwritten is written, is the form has been signed, and the purchase of 2019, the vehicle, which vehicle was actually being bought and purchased or not, which is here. And as most of the forms are still being actually handwritten, and how do you read these forms and use this form for the context layer itself? And as I said, like this is the markdown looks like. We actually pull all the information, especially the information like 666 111235, and we can actually have the identification number. The great piece is that it is in the markdown, we did end up picking the column, but if you look at the JSON results itself, we end up cleaning those information when we are creating the JSON schema, because that's where we do the resolution and cleaning of the data itself, so the data can be used in your pipeline as you're trying to pull the information from these documents. I'm going to pause and look for any questions. There are no questions at the moment, so I'm going to keep moving. And if there are any questions, please drop in the chat. So here, so as you can see, like you can also see a transaction, which transaction was made at what time for description of what purchase. So all those information we are taking out of the JSON, this PDF, which is a handwritten PDF completely scanned, and creating that information in two different ways. One actually for the AI workflow itself, which is in the markdown, and thus the graph itself, or actually in the JSON that can be used into your legacy workflow and that can directly go into your warehouse. Tomorrow, if we end up receiving a new file or end up receiving a new information, we automatically will pick those file into your Amazon S3 and will create the markdown without you noticing. The other piece I want to also call out, which is also can be used for auditability. If we receive a new version of a file, then we actually keep the both previous markdown and the new markdown because for the auditability reason, just in case if the file has not changed, but the new information has file come in, which a new page or information itself has changed. We also do deduplicate. So if there is a 2 or 3 different files exactly same, then we dedupe the files, making sure that we are not running the compute extra just to create your information or run the document intelligence on these files. The last thing which I also want to call out is that all these information is being stored in the Apache Iceberg in your account. So you can actually use that information for your own purposes as we are using that Iceberg to create the Memgraph itself. And our model, which we have created to actually run the document intelligence, completely run air gapped in your account. So if somebody actually have a privacy needs where they cannot let the information leave the on-prem information or whatnot, we run the model itself in the customer's account if need to be, so that they can own the inference and the model itself as looking to actually pull the information from any sensitive document or any sensitive PDF files or even Excel or Word document. So now what happens? After we have to create the markdown, and I can click another one, after we create a markdown, I've created the schemas and created the other information from here. We end up creating the graph. The most amazing thing about these files, why the graph plays and Memgraph plays very critical role, because sometimes the information doesn't exist in one place. As you can see, the Victor information exists here, but the Victor information might exist in other places. Let me actually open this one in here too, which is the Victor information exists here too. So what happens is that how do you even know into two different documents are related to each other and how they are related? And that's where the context matters a lot. And that's where graph matters a lot. And I'm going to go to now Memgraphs. What we do, we actually take the documents, so you can say which source contains what documents. And then we actually define the documents in every segments. And those segments can actually contain the information like Florida, for example, which is a state. But that state is mentioned in other location, which is also comes from different documents. So what we do, we actually now create the entities, which is based on the JSON extraction we've created, and use those entities to even connect two different documents in the file itself. Now you actually find the relationship between documents and go, what actually creates the relationship on the file. So here, if I look at the Carlos, actually is related to the Apex auto sales, but Carlos information comes from this segment and our auto sales comes from different places. So you can actually go and actually figure out which information are related into what pieces of document itself. Let me see if I can find as I said, here. This is another one, which is, you can see this segment talks about all the purchase of this, the BMW, which I was just talking about. We know that which segment it comes from. We actually have full information of the markdown itself in the graph too. That helps us to actually ask questions and pull the information and use it for the either search purposes or actually building any workflows on it. The best part is that if you get new information, your graph is automatically being created and automatically being audited based on when the information was added. One thing we also add in the graph, which you also, which information is handwritten, which information is not. The reason why we do that, because handwritten information can be tricky. Sometimes it's hard to get those things right based on how people write it. We want to add those information as a part of graph itself. So when you are pulling the information, we have the complete audit log where the information comes from handwritten or not, thus giving you confidence into the information is correct or not itself. Now, let's actually ask some questions on the document itself. So I have prepared some questions. I'm going to refresh it. So for example, the Victor Melnick passport details. When you are looking for the passport details itself on the document, and you might ask a question, the details might be as a part of two documents instead of one document itself. And then how do you even actually go figure out, based on the other information, as you said, some of the information is scanned, where itself the passport details is, and how do I actually know those information is coming from? And this is where we actually got like a Victor Melnick as a Ukrainian passport number, issue date. And the information does not present in one place, but three different documents we're pulling the information out. And the reason for us showing that value is because this is where the graph plays a bigger role, because sometimes you might actually have a passport number for some of the use case, but passport numbers might actually exist in 3 or 4 different places. You're trying to pull all the information out in all different places instead of just showing it to one document itself. Let me ask a few more questions here, which is, who's the beneficiary of Creston Holding? And as I ask these questions too, you'll see that it will actually go look into, and this is completely running on the graph. There's no vector database, completely running on the context which was built through Quark Labs using our document intelligence and the document intelligence of the platform which is coming from. Let me ask one more time. And this was any crash transaction done by Carlos Reyna? And this was the great one, because what happens, like there's no crash transaction there by Carlos Reyna. So what we do, we look into the information, which is where the cash transaction for Carlos Reina, what kind of cash transaction it is, and sometimes the information may not even exist. In what case, what happened? So give it a second, it will come back. Sorry, this is all running on my laptop, so I hope my OpenAI. So here I found the relevant evidence in the graph, which is where it looks like my OpenAI might be down. Based on that, yeah, OpenAI error happened, something. So apologies for that. As I said, this is a live demo. It was not down here, but it was down here. But again, let me try again. Maybe something. We'll try again. But in this time, what we do, like we just want to look at like here. You can see the Carlos Reina is listed as the president and CEO of Alex Alex, and then the total cash received by Alex Cash is this much. So we did find the information. Is unable to parse here, but the information is coming from different places in the graph as we are pulling the information together itself. Let me ask one more, and then I'll look into the what did the James Whitman W8BN says. And the value is that because then you can see that all the information is automatically comes from the relevant evidence in the graph. So we are going to the graph and creating those information, and we are pulling the information in a way based on all the entities which was created in the graph itself. Here, WGA says lists James Whitfield Part X as substantial UX owner, address, and then what is a TIN number and other information. So you're able to quickly find this information. And this has not been possible for one reason, if the graph was not there. But if it's also not possible for like how do you even parse this information at the scale? Because we have been working with the customers who have millions of documents sitting in the places. And the biggest challenge comes in the millions of documents. How do I even parse the information, and how do I even create the information by connecting the graph? The biggest challenge comes into what entities are needed and how do I put the entities. And this is where you can either create the entities with us into our extraction logic, or if you do not know what entities you created, we automatically create the entities based and do all kind of entity resolution based on this JSON results, which is actually part of the every documents we pull. The JSON results helps us identify and create the information based on names and different identifier and matching and connecting the different documents in your organization so you can understand which documents actually is related to what documents on why. That is the demo. Any questions, anything else folks want to see? So I'm going to pause and look for questions.
It doesn't seem like there's any questions.
Wow. I will post my email address here too into the chat, which is very quick. Vishal at quarklabs.ai. Feel free to send me an email if there are more questions. But again, if there are any questions, let us know. What we also do is one of the things which I want to show is like all the jobs. So every time we run something, we keep the logs of when the things actually ran, how the things came through. So here we actually know that we are running this completely, the VLLM side of it, and we actually keep all the different stages to actually keep the information. Here, there's a question here. Please share more about the approach when customer doesn't. It's a great question. So one of the things that we know, Anya, that the customer we are talking to is in a financial area again, and they are actually care about the in creating the universal context across the documents which they are serving. The one of the key piece happens, like you don't really know all the time what entities to actually go figure it out, but you do know some universal entities, you do know some universal use case. The what we do, the way we start, is that, as I said, we know that this you care about KYC use case, so we actually know that some of the common entities that needs to be actually created out of the document. We also make sure that we are pulling all the common entities from the document too, even though customer has not asked. We can use existing ontologies if needed, but sometimes the existing ontology over a million documents is hard to define. It is great when you have subset of information, but the ontology over a millions of documents becomes a challenge how to keep up with that. But if you have existing ontology that actually expedite the process itself, but if you don't, then how do you actually? This is why we have created the context based on how what mentions and the classification. This is the classified as a cache player. So then we use the entities and classification to manage those itself. If you don't, let's say if you do have an existing ontology, which is Carlos Rena signed up for the cache player, that can also be used. So this, you see that there's a two pattern here. We knew that we want to actually find the existing ontology. We use that too, but those ontology doesn't exist. We find a relationship between through the entities. We also do that in the graph too. So use the existing ontology if you have. If you don't, then we actually connect the graph. For example, if you come up with a new pattern or new entities, which we did not do it, the best piece is that all the information is already in the graph, all the entities are already being extracted. We can recreate the ontology in the Memgraph quickly based on your evolving use case in the future. That is true. So that is, I think that is a great question, because again, as I said, if we are talking to financial customers, most of our customers are in the finance state, one or two customers in healthcare, but that actually helps because when we go into the customer's account and if they have maintained their own ontology we can use. If they do not, we knowing what domain they operate, we use a generic industry ontology. Let me know, Anya, if that answers your questions. One of the other piece I'll say, which we learned with our customers, is that entity resolution itself. As you said, sometimes the graph is actually comes in different places. You might have beneficiary name, but in other places name itself. So what we do in order to even resolve the entity is by looking into the key of the data itself. So when we look into this data, because the signature data is there, what we do is like we actually use multiple ways of normalized values and the IDs to actually pull the information and connect the information, and thus the resolution of the entities and ontology too. Because sometimes you might actually have a name and you might actually have two names but two different passwords. You do not want to connect them, but you might have a name with the same passport but some actually have bad written handwriting. We actually end up fixing the bad written handwriting because the passport name was similar.
Any additional questions? Cool. Well, I think if there's no questions, I will say thank you to Vishal for a great demo. So it was definitely short and sweet, but to the point and helpful. Any final thoughts, Vishal?
No, I just like reach out to me if there are any questions. I would love to actually connect to even get your perspective. If somebody wants to actually just do just the geeking of the why the graph and why the ontology and what is the difference between ontology and there's a question: is there a language layer separate to the entity ID in the graph? Let me understand the question before I. So when I say is there a language layer separate to entity ID layer, you're talking about in the Quark Labs, do we read the entity differently than something else? We do. I'm glad you asked it. So thank you. So when you talk about international language, so the way we our document extraction works, we are actually looking at the extraction. We can do almost like right now we have tested with 20 languages and it works in all those languages. What we do when we pull the information out on the entity itself, we connect the two different languages together when it comes to the entity itself. So when I talk about entity resolution, we do also look at the international languages because sometimes we can have two different documents in two different languages, but may have a similar passport number or same ID. And then using even two different languages, we can connect two documents to.
Amazing. Cool. Well, thank you so much for all the questions. Thank you, Vishal, for the presentation. Stay tuned, everyone. We'll have Vishal back in a couple of weeks to talk about the audit and how
Awesome.
companies do audit. So
Awesome.
thank you so much, and have a good rest of the day and week. Bye bye.
Awesome. Awesome. See you. Thanks, everyone.